All right, compound events is an event made of two or more. So yesterday was the first day we talked about what happens or how to find probability when something has already happened. So now we're going to say, well, what if two things have already happened? So experimental probability means it has already happened. Somebody already did something. So in number 1, it says Ryan rolls a die and flips a coin 20 times. The results are shown in the table below. He already did it. Based on the results of the experiment, what is the experimental probability Ryan rolls an even number and flips tails? So in your table with the list of things that happened, you're going to circle every time it's an even number and tails. So 2 and tails is even and tails. 6 and tails. I think I got them all. I might not have. So how many times did we get an even number and tails? 1, 2, 3, 4, 5, 6. Oops. 6 out of 20 times total. I can divide both of those by 2 and get 3 out of 10. How does the experimental probability compare to the theoretical probability of getting an even number and flipping tails? So, theoretical is before it happens. So this is what should happen. So what should have happened was we should have had an even number and we should have flipped tails. So tails is 1/2 and even number is 3 out of 6, right? So if I multiply, I get 3 out of 12, which is the same as 1/4. So 3/10 and 1/4, they're a little bit different. 1/4 is equal to 0.25 and 3/10 is. So you can see they're really close, but they're a little bit different. So number 2 says, Sammy conducts an experiment with 3 quarters. He counts the number of heads and tails for each flip of the 3 quarters. Sammy records the results in the table below. According to the table, what is the probability of flipping 2 heads and a tail? So 2 heads and a tail is right here. 15 out of, you're going to have to add. I think it's 50. I might be wrong. Now, to turn that into a decimal, it's top in, bottom out. Now it says, how does the experimental probability compare to the theoretical probability of getting 2 heads and a tail? So this is what should have happened. So theoretically, we want probability of heads, and probability of tails. So if we multiply all of those together, what do you get? And then make sure that you turn that into a decimal. So that you can compare. All right. Xavier rolls a die and flips a coin 20 times. The results are shown in the table below. What is the probability Xavier rolls a floor 4 and flips heads? So we have 1, 2 out of 20. And you can simplify that. Now the theoretical probability means it hasn't happened yet. That's where we multiply. So probability of getting a 4 . All right, Talia plays a board game with a friend. She uses a table to record the results of each roll on a standard die. Based on the data in the table, what is the probability of rolling a 5 on the next roll? Well, how many times did we roll a 5? 8 times. Out 4 plus 2 plus 6 plus 5 plus 8 plus 1. 10, 26. Don't trust me on that. 4 plus 2 is 6, plus 6 is 12, plus 5 is 17, 25, 26. Make sure you simplify by 2. Based on the data in the frequency table, what is the probability of rolling a 2 or 3? So you are looking for 2s or 3s. 26 is still your bottom number. How many times did you get a 2 or a 3? Without looking, Carrie selects a number from the tiles shown below. What is the probability that the tile Carrie selects shows a prime number? Prime numbers are numbers that cannot be divided. So, I honestly always forget if 1 is a prime number, but maybe 1, 3, 5, 7, 11, 13, 17. All of those are prime numbers. You can't divide them. So how many of the numbers up here are prime? Five out of how many total? 8. Ms. Wynn spins a spinner with 5 equal sections 50 times. The results are noted in the spinner below. Here's your key. It has already happened. She already did it. So you have to use what actually happened. Ms. Wynn spins a second spinner with 3 equal sections 50 times. The results are recorded in the table below. 2 different spinners. Based on the data, what is the experimental probability that Ms. Wynn will spin a diamond and a C? So you need the probability of a diamond and the probability of a C. What's the probability of a diamond? 10 out of 50. What's the probability of a C? 16 out of 50. Now, you can simplify first, or you can multiply and then simplify later. Based on the data, what is the experimental probability that Ms. Wynn will spin a triangle and an A? So you need probability of a triangle and probability of an angle is 10 out of 50. Probability of an A is 20 out of 50. Now you can simplify. In the end, you can simplify at least by 10, probably by 100. Four yellow, 3 blue, 3 green, and 2 orange marbles. If Molly removes one marble without looking, records the color, and places the marble back in the jar before drawing again, what is the probability she will remove 2 yellow marbles? So, the first time she's going to draw a yellow. Second time she is going to draw a yellow, and then we're going to multiply. How many marbles are all together? Yeah, you're going to have to add 4 plus 3 plus 3 plus 2. I think you get 12. And we want a yellow marble. So there's 4 yellows. We put the marble back in, so we still have 12, and your top number is still 4. Now you can simplify first, or you can simplify in the end. If Molly removes one marble without looking, records the color, and does not replace the marble before drawing again, what is the probability she will remove 2 yellow marbles? Is still 4 out of 12. The second time, though, we only have 11 marbles because we don't put it back. How many of those marbles are yellow? Right? Remember, the first time she took a yellow out, so you only have 3 yellows. So your top number should be 3. Now go ahead and multiply for your answer. You can simplify by 4, at least by 4 in the end. A bag of game markers contains 4 red, 5 blue, 3 yellow, and 3 green. If Mario reaches into the bag and pulls out a game marker without looking, what is the probability he will not pull out a blue game marker? So probability of not blue, you're going to add 4 plus 5 plus 3 plus 3. I think you get 15. How many are not blue? And then you have to simplify, but that's it. 2 bags each contain 5-letter tiles. The sample space is shown below. Jennifer selects 1 tile from each bag without looking. What is the probability that Jennifer selects 2 vowel titles? So bag 1, we want the probability of a vowel. Vowels are A, E, I, O, and U. How many vowels are in the first bag? 1, 2, 3 out of 5. Now the second bag, she also wants a vowel. How many vowels are in the second bag? 2 out of 5, right? E and O. So now you are going to multiply those 2 fractions together and then divide to turn it into a decimal. During a school carnival, the student council booth has a quarter toss. The quarter is tossed in cups placed at varying distances to earn points. The more points earned, the bigger the prize. The table shows the results from the booth within the first hour. What is the experimental probability that a participant receives a 5 or 10 points on the toss? 5 or 10 points. That would be 8 out of how many together? You're going to have to add 20 plus 12 plus 8 plus 5. You're going to simplify. Lizbeth conducts an experiment with 3 quarters. She counts the number of heads and tails for each flip of the 3 quarters. Lizbeth records the results in the table below. According to Lizbeth's table, what is the probability of flipping 3 heads? Write your answer as a percent. So how many times did she get 3 heads? 10 out of how many times total? I think 10 out of 50. Now we're going to write that as a percent. And then B says, what is the theoretical probability of flipping 3 heads? Write your answer as a percent. So this time you're going to have to multiply. Probability before it's happened. And then you're going to turn that into a percent.